Hi everyone, we're going to start by going over an introduction to RStudio today. And after this video, you'll be able to do homework 1. Homework 1 is a homework that is basically just simple interfacing with R, which is what you'll learn how to do today. And then you can complete homework 1. In the file section on Canvas, you'll find all the files we're going to use in the course. It's split up into different folders. This is going to be in Exam 1 material because this first 2 weeks of the course is going to be material covered in Exam 1. And you'll find this intro to R file, this intro to R dot text here, okay? And you can go ahead and download that. You can click these dots and click download, all right? And it'll give you a text file. And that text file will look like this. I know it looks possibly kind of scary, but we'll walk through it together. And what I'm going to do is I'm going to highlight and copy all of this. I'm just going to copy and paste it into R. I keep saying R, what I really mean is RStudio, which is a more modern, more visually pleasing and better user interface than R itself. So once you have R downloaded, this is what it looks like, RStudio. And we're going to go ahead and click this plus in the upper left-hand corner to make a new file, make a new R script, okay? And I'm going to just paste everything I copied into there. All right. And we're going to walk through this line by line. So we see we have this top piece, and this is where we can edit different commands and run to see what the output looks like. In the bottom here, this is where the output is going to be. And in this bottom, in the upper right hand corner here, we see a little broom. What this broom will do is it'll clear this console so we have a fresh slate. So if I click that, it'll clear everything here, just to have a nice fresh slate to start with. And we'll see later on what the right hand side here can be used for. So R can be used as a basic calculator. For example, 2 plus 3 times 5. What would that be? Well, 3 times 5 is 15, right? Order of operations says you do multiplication first and then add 2 to that afterwards. So this should be 17 because 3 times 5 is 15 plus 2 is 17. So when I'm on this line, see my cursor is currently flashing on that line. When I click run, it's going to execute what that line says to do. All right. So I'm going to click run and it calculates it. 2 plus 3 times 5 is 17. And I have these notes in here that tell you that try to explain what each line is doing so that when you're walking through this, you have a description of what's what. And anything after this symbol here, R will ignore. So that's why it doesn't recognize anything after that. If I deleted this, what would happen if I ran this? I get this error because it doesn't know what this is. R doesn't note the order of operations as an R command, so it's giving me an error. So I put in this symbol to say, okay, ignore everything in this. It's saying everything after this symbol is not code or commands. Just ignore it, okay? And then when you run that, it only ran the highlighted portion. When you run that, it gives you the output, okay? Now log 10 if you wanted to do logarithms. In R, log, if nothing else is specified, gives you the natural logarithm. We are not going to use logarithms in this class, but again, showing R can be used as a calculator if you wanted. If you wanted to do exponents, you can. 4 and then this little upper caret 2 gives you 4 raised to the second power, which is 4 squared, which means 4 times 4, which is 16. I'll run that and you see it gives me 16 here. And I'm going to just keep going through this. 3 divided by 2 should give me 1.5. SQRT is for square root. SQRT is square root. So the square root of 16 is 4. See how that gives me 4. ABS is absolute value. Remember how absolute value works. If what's inside is positive, it stays the same. If it's negative, then it makes it positive. 3 minus 7 is negative 4. So the absolute value gets rid of the negative and makes it a positive 4. EXP is, if you remember from a college algebra or pre-calculus or something, you have that magical number E, which is 2 point, and some decimals. And that's what this does. This is going to give me e to the power of 2. And this is a number that we're not going to be using in this class. And notice how in this bottom console, I'm starting to get filled up at the bottom. And I like to keep everything nice and clean and tidy. So every so often I like to clean it up by pressing this broom just to have a fresh panel to work with. We could do integer division, meaning, like here I did 3 divided by 2, which is a decimal 1.5. But if I did integer division, it would say, how many times does 2 go into 3, ignoring the decimals? It would go into 3 one whole time. So this would give me 1 instead of 1.5. So here, 15, integer divide 4. How many times does 4 go into 15? Well, it goes in 3 whole times, right? Because 4 times 3 is 12, which is still smaller. But as soon as I go 4 times 4, that goes 16, which is higher than 15. So it goes in 3 whole times. And we already talked about what this means, the little comment line. Okay. Moving on from that initial section, we're starting to get into how we're really going to be using R and working with data here. So we can assign a value to whatever we want. Here I'm assigning a value to x. This x, I can make it whatever I want. It doesn't matter. What I'm saying is I'm saving x as a shortcut. I want x to be a shortcut. That's what this arrow means. I want x to be a shortcut. The arrow is pointing to x. And I want the shortcut to be this. So instead of typing this over and over and over, I can just type x out. So if I run this line, notice down here, it doesn't tell me what this decimal is, right? It's just saying, okay, you have successfully saved it as x. So if you wanted to see what that decimal is, instead of typing this out over and over, I can just type x. And I can type commands here in the bottom. The only difference in typing it in the bottom than in the top is that we can't go back up and edit it like we can in the top, right? So instead of typing out log of 2.8, so on and so on, I can just type x, and it gives me that number. I have saved x as this number here. We can do different commands with numbers. We can take floor and ceiling. Think about what that means. The floor is below you, the ceiling is above you, right? Floor will round it down. So if I round this number down, I get 1. Similarly, if I round that number up, I get 2. Okay? Now you can save, I have x saved as this number here. X doesn't have to be a number. It can be a list of numbers like I'm doing here. So now I have x that I'm creating a shortcut. I'm saving it as this. This is us combining a bunch of numbers together. 1, 3, 2, 10, and 5. This C stands for concatenate. I'll put a note here. C stands for concatenate. I think I spelled that right. And it's a command that says, okay, we're going to glue all of these numbers together. We're going to glue all of these numbers together so that they are one entity. So x is not going to be a single number, but it's going to be a list of numbers. So I'm going to run this. And now x is a list of numbers. So whenever I type x out, it is now a list of numbers instead of a single number. And this is when we can start looking at these other panels. Notice as soon as we saved x as something, it started populating over here. This upper right hand window gives us everything we have saved in our current R session. So right now we have this x saved in here. and what that is. And it's good to keep track. It's good to have this to keep track, because it could be the case when you're doing a lot of stuff in R, you have a bunch of stuff saved and it could be unorganized and you're not sure what's what anymore after hours of programming, and you end up having this nice little shortcut here to tell you what's what. We can create some shortcuts. So like the colon shortcut would give me everything 1 through 5. So instead of typing out 1, 2, 3, 4, 5, I can use a colon, 1:5. And I'm going to save that as y. And these x and y names don't matter. I can put anything here. Okay. So I'm just choosing to say x and y to be simple. So now y is, you can see up here, it's populated now. It's 1, 2, 3, 4, 5. X is 1, 3, 2, 10, and 5. And we can start doing arithmetic with these things, right? And another thing to note is this is a nice shortcut. For example, what if you needed all the numbers 1 to 1,000,000, right? It would take you a very, very, very long time to type that all out and hope you got all of the numbers and none of them were typoed, right? You can do 1:1,000,000 and have it all done there for you. We can do arithmetic with these lists of numbers. These lists of numbers, we usually call them as vectors. So we can do arithmetic with these vectors. For instance, y plus 2, right? So I'm taking this whole 1, 2, 3, 4, 5, and I'm doing plus 2. So that's going to add 2 to all of these. 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2, and 5 plus 2. I run that and I get the output here. I added 2 to all of the values. I can multiply all of the values by 2. Okay. I can square all of the values. Right, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. I can do the reverse. I can take a number and have everything in the vector be the exponents. For instance, 2 to the y power. That's going to give me 2 to the first, which is 2, 2 to the second, which is 4, 2 cubed, which is 8, 2 to the fourth, which is 16, and 2 to the fifth, which is 32. Okay. But notice I've done all these calculations, but y is the same. Y is still 1, 2, 3, 4, 5. That hasn't changed. It's only going to change when you reset it with an arrow. That's the only time it's going to change. So right now, when I type out y, it shows as 1, 2, 3, 4, 5. But as soon as I override it, if I click run here, I replaced y with y times 2. So now when I look at y, it is now the original times 2, right? And now I overwrote it and I can't get it back. I can't undo this. It is now updated in here. All right. Moving on. You can do more than one command in a single line of R code. If you wanted to do that, you could use a colon to separate the commands. I don't tend to do this that much just because it can become more cluttered and less organized. But I could create X and Y in the same line if I wanted to. And just as I did arithmetic, adding, subtracting, and such with a vector and a number as I did above, I can do this stuff with two vectors. So X plus Y will do exactly what you think it'd do. 1 plus 1, 3 plus 2, 2 plus 3, 10 plus 4, 5 plus 5. Right, we get 2, 5, 5, 14, and 10. X times Y will do 1 times 1, 3 times 2, 2 times 3, 10 times 4, 5 times 5. X divided by Y will give me 1 divided by 1, 3 divided by 2, 2 divided by 3, 10 divided by 4, and 5 divided by 5. X to the power Y will give me 1 to the first power, 3 to the second power, 2 to the third power, 10 to the fourth power, and 5 to the fifth power. Okay. And Again, this x isn't any different than this, so we don't have to run this line. In case you accidentally delete it or something, you can click this broom to clear everything in here. And if you did that accidentally, you can reset it by just typing it out again. But there's other things we can do. We can do the sum. Remember, sum means you're adding things. So what do I get when I add together 1, 3, 2, 10, and 5 is what that's asking. I get 21. If I added up all these together, you get 21, and you can check that by hand. You can sort, right? So I had 1, 3, 2, 10, and 5, and I sorted them. This is in least to greatest order. If you wanted it greatest to least, biggest number to smallest number, you can add this. You can add this argument in here called decreasing equals t. T stands for true. Okay. T stands for true here. So we're saying, okay, we want it to be true that this thing is actually decreasing instead of increasing. And that'll make it start high and end low. And you can type out true all the way, or you can do just a T, and you'll get the same results. Length will tell you how many things are in the list, right? So how many numbers are in here? We can count. There's 1, 2, 3, 4, 5 of them. So length will give me 5. There's 5 things that make up X. All right. Let's start scrolling down a little bit. I'm going to go ahead and clear this. Okay. And we can start looking at pieces of these vectors. You can start to see how we're going to start working with data, right? We can store data like this. It could be one vector, could be an entire data set and such. And we can start looking at certain features. For example, the third element of X. What is the third thing that appears in this? So we can see here the third thing that shows up is 2. So this is going to give me 2. These little square brackets tell you what piece of the vector or list you want to look at. So this is saying I want to look at the third. This is saying I want to look at the third through the fifth thing in the list. So the third through the fifth thing in the list is 2, 10, and 5. If you put a minus, that means I want to look at everything except what's in that spot. So everything except the second position. The second position here is 3. So looking at anything except that would give me 1, 2, 10, and 5. Okay. What if I wanted to know what's everything bigger than 3? So I can say, okay, I'm looking at the vector x, and then the square brackets. And I say, okay, I want to look at everything that is bigger than 3. So x greater than 3. So the things in x that are greater than 3. And the things it says is 10 and 5. And we can look back and say, okay, yeah, 10 and 5 are definitely bigger than 3. And out of this entire list, those are the only ones that are bigger than 3. Right? It didn't pick up 3 because 3 is not bigger than 3. When we create vectors, like here I created a vector x, which was numbers. It doesn't have to be numbers. It can be characters. It can be words. So I'm going to create a vector. I'm going to call it colors. This name colors, it can be whatever you want. I'm just calling it colors right now. And if you want it to be words or characters, you have to put the words or characters in quotes, or it's going to think you're talking about a number or some object inside of R. And you know, that's not what we want to do. We're just typing out these color names: green, blue, orange, yellow, red. So now I have this colors here, this vector of colors, right? So if I type out colors, it gives me this vector, this list of these colors that I created. And I can actually give labels to each of these numbers, 1, 3, 2, 10, 5. I can label them. For example, if we're doing a problem involving different color marbles, you know, maybe there's 1 green marble, there's 3 blue marbles, 2 orange, 10 yellow, and 5 red marbles, okay? We can assign labels to each of these numbers in a vector, okay? So to look at if there are any labels assigned to the numbers in a vector, we can use the command names. Names will look at this vector x and say, are there any names associated to those values? And it's saying no, there's nothing. There's no names associated with those values. And it's like, okay, so let's give them names. So we're going to create labels for the numbers, and the labels are going to come from our colors, which are these. So I'm going to run that. And now, before, when I typed out x, right, if you typed out x before, it would just give you 1, 3, 2, 10, 5. But now when you type x out, look, it gives you these labels. It's not just 1, 3, 2, 10, 5. It's, okay, green there's 1, blue there's 3, orange there's 2, yellow there's 10, red there's 5. So you can start to see how we can use this to build our own data sets. Maybe you wanted to know specifically how many were green. So again, you can use the square brackets to say, okay, we want to look at a particular part of this list or vector. The part we want to look at are the green ones. So which is associated with green here? And it's saying there's 1. And in a table like this, we could look at it. We could just look at it. But if the table is much, much bigger, it's harder to look at. So we can get more information with these kinds of shortcuts. And if you wanted to remove the labels, maybe you didn't want these labels anymore, you can just replace it with null again. Remember, before, when there were no names, it gave us null. So if you want to remove the names, that's how we're going to do it. We're going to say, okay, the names, all the labels on those numbers, we're going to make them null. We're going to make them nothing. So now when you type out x again, so here we can type out x again, it's just 1, 3, 2, 10, and 5 instead of it giving it to us with all of the labels. I'm going to go ahead and clear the console again. All right. Some more shortcuts. The sequence and SEQ for sequence and rep for repeat or repetition give you convenient ways to construct vectors with a certain pattern. For example, SEQ10 gives us everything 1 through 10, a sequence of 10 numbers. We saw we could do that already with the colon. Remember, if I wanted to do that shortcut, I could do 1:10, and you could get the same result. But sequence, we can do more with it. For example, we can say we want a sequence that starts at 0, ends at 1, and has 10 numbers in it. Okay, so remember we saw length above. Where did we see that? That said how many elements were in the vector. Okay, now we're saying we want a sequence from 0 to 1 that has a length of 10, that has 10 numbers in it. And this gives us that sequence. Okay, we can also say, okay, maybe we don't care about how many there are at the end, but maybe we want the intervals to be size 0.1, right? Here the intervals are size 0.111 repeating, right? This is basically 0, 1/9, 2/9, 3/9, 4/9, so on and so on. Whoops. Okay. So this is saying, okay, we're not going to specify how many there are, but rather we're going to specify the length of the interval. So we're starting at 0 and ending at 1 and going up by 0.1. So 0.0, 0.1, 0.2, 0.3, so on and so on. We can use the rep command for repeat. We're going to repeat 1 3 times. 1, 1, 1. Or we repeat 1 3 times. 1 shows up 3 times here. We can make patterns. Remember, C means we're going to combine these things as a vector, right? So we're going to combine these patterns as a vector. So we're going to repeat 1 3 times. So it's going to be 1 1 1. Repeat 2 twice, 2 2. So it's going to be 1 1 1, 2 2, and then repeat -1 4 times. So this is going to give me 1 1 1, 2 2, -1 -1 -1 -1. And again, this doesn't work just with numbers. We can also play this game with words. For example, if you wanted to repeat the word small 3 times, or repeat the word small 3 times and the word medium 4 times, or repeat a pattern, right? We're repeating, right? We made this low high as a vector together, and then we're going to repeat low high 3 times. So this is going to be low high, low high, low high, right? So if you have something that you're trying to build that follows some sort of theme or pattern, these sequence and rep commands can be very helpful. And then some of the ways we're going to be calculating different values with these. We've seen this already. I'm going to clear this again. I'm going to make a vector x, which is all of these numbers. So when you type out x, it's just all of these numbers. Instead of having to type them out over and over again as a shortcut, we save it as x. We've seen sort, low to high, high to low. We've seen sum. And now here's other things we're going to look at. We can look at the mean, which is the average, the median, which is if you wrote them all out and looked at what was in the very middle of the list if you wrote it from least to greatest. Okay. We can look at the variance. We'll talk more about variance and standard deviation in a bit. Variance, standard deviation is SD. We'll talk more about what that means later. And then we can look at different percentiles. Right, we can look at the 25th percentile, and we'll again do more of this later. We can look at a bunch of percentiles at once. We can look at a general summary of the vector. It can tell us the minimum, the first quartile, median, mean, third quartile, and the max, right? Kind of gives us all of this same information plus the mean. And then the IQR, the interquartile range, which is the difference between the third quartile and the first. The third quartile being what is bigger than 75% of the data, and the first quartile being what's bigger than 25% of the data. And we're going to talk more about that as we move on together. This is just a general introduction to R and how we will be using it moving forward. With this, you're able to complete the first homework. If you have questions on anything in this document or anything in R so far based off of this, or questions on the first homework, please do email me and let me know. Thank you.